Hi, welcome to the section of Hive. Hive is the most important ecosystem component of Hadoop, and it's again the widely used ecosystem component. In this section, we'll be looking at what is Hive, who has invented Hive, and what is the architecture of Hive, and how does Hive stores its data. Okay, let's quickly see what is Hive. Hive is an data warehouse that runs on top of Hadoop. It's a general purpose, scalable data processing platform which has been invented by Jeff Hammerbacher and team who belong to Facebook. Okay, it allows user to write its queries in SQL-like language called HQL, Hive Query Language. But again, these queries will be converted to MapReduce in the background. So when you have some data and when you wanted to give some tabular format to the data, then Hive is the best option. Hive allows SQL programmers with no MapReduce experience to use warehouse and they can query their data. They can do their ad hoc analysis or ad hoc querying or data mining, whatever they want. They can do it using Hive. Okay. Not only these features that Hive will offer, Hive can also be integrated with some visual analytic tools like Tableau and R. Yeah, so Hive is the most widely used ecosystem component when you compare with other ecosystem components of Hadoop. Okay, now that we know what is Hive, let's look at the architecture of Hive. When you look at the architecture of Hive, you'll look at three main components. Okay, one is command line interface, another thing is web interface, third thing is thrift server. Okay, so what is this command line interface? It's nothing but in Hadoop, when you type Hive and press enter, you will be entered into Hive shell where you can write your Hive queries. That means accessing Hive through command line interface is nothing but this option. This CLI would give you one option to access Hive, and you have another option to access Hive is web interface. You have something called Hive, using which you can access Hive through web interface. And when you wanted to access Hive from other applications, maybe from other Unix servers or something, then you can have your JDBC and ODBC connectivity, which will be authenticated by thrift server. Then you can connect to your Hive and run your queries. So these are the different ways of accessing Hive. One is CLI, another thing is web interface. In a web interface you can access using Hive. You have something called thrift server. In thrift server you have JDBC and ODBC connectivity, using which you can connect to Hive. After connecting to Hive, when you write some queries, so then your driver will come into picture. So what is driver? Driver is the combination of compiler, optimizer, and executor. Like I said previously, whatever queries you write using your HQL will be run as a background in it will be run as MapReduce in the background. So in order to convert your Hive queries into MapReduce jobs, your compiler will do that. It will convert your Hive queries into MapReduce jobs. You have something called optimizer, which optimizes your Hive queries. If there is some scope for optimization, then optimizer will do that. And finally, you have executor, which will take your Hive query and execute it in the background. It will execute your MapReduce jobs. So as soon as your MapReduce jobs are invoked, then all your daemons will come into picture, which is nothing but your name node, job tracker, task tracker. All these things will be coming into picture. So that's why Hive is a data warehouse which is running on top of Hadoop, right? So its default or its storage mechanism is nothing but our HDFS. So whatever you load into Hive will be stored in HDFS. Okay, so how Hive will know which table content is stored in which region? So then where your metastore will come into picture. We'll discuss in detail about metastore in our next slide. Before that, let's quickly concentrate again on the ways of accessing Hive. The ways of accessing Hive are using your command line interface, web interface, or using thrift server. So once you connect and submit your queries, then driver will come into picture, which is a combination of compiler, optimizer, and executor. Compiler converts your HQL query into your MapReduce, and optimizer optimizes when there is scope for optimizing your query, and executor is the one which launches your MapReduce jobs in the background. Right? So as soon as your MapReduce jobs are launched, then your all the daemons will come into picture, like job tracker, task tracker, name node, and data node will come into picture. That's the reason why we call Hive as a data warehouse running on top of Hadoop. Okay, let's quickly see what is this meta store and what are the different types of meta stores in Hive. There are three types of meta stores in Hive. One is embedded meta store, second thing is local meta store, third one is remote meta store. Basically, what is this meta store? If you have something like 10 tables, and each table will have some unique data. When I say data, it's nothing but it's a file stored in HDFS. So when you are storing some data into your Hive table, and after 2 months or something down the lane, when you are querying your data has to be whatever querying you do, it has to be there, right? So Hive should understand where this particular data is there. In order to make Hive understand that, we should have something like meta store. Which table data is where, in which location. Okay, so that meta store can be configured in three ways. Let's look at embedded meta store. In embedded meta store, all the driver, meta store service, and your actual meta store database will be running using a single JVM. We know what a driver is. Okay, Metastore service is a service provider which allows the driver to connect to the Metastore. Okay, when I say embedded Metastore, the database that stores the metadata of the Hive will be Derby. Because in embedded Metastore, everything will be running in a single JVM, so only a single user can log into Hive at a single point of time. You cannot allow the multiple users to log into your Hive at a single point of time. So this embedded Metastore can be used in a pseudo mode cluster, which we are practicing currently, right? So because in that all the drivers, Metastore service, and Derby database will be running in a single JVM. So this Derby will have the actual Metastore. But if I wanted multiple users to log into Hive, how do I do that? I do that using local Metastore or using remote Metastore. So what's the difference between these two? In local Metastore, your Hive service, your driver and Metastore service will be running in a single JVM, and your database will be there in another JVM. When I say the database, you can use MySQL or Derby here. Okay, both will support, but people normally do use MySQL for your local and remote Metastore. So like I said, there is only the difference is your Hive allows you to make multiple people log in when you are using local Metastore. Okay, even here you'll have your driver and Metastore service and the database that stores the Metastore. So when it comes to remote Metastore, everything will be running in a separate JVM. Okay, so this remote Metastore is basically used for production cluster. Okay, whereas your local Metastore will be used for standalone mode cluster. Right? So these are the three different ways in which you can configure your Metastore. Okay, finally your metadata of Hive will be stored in some database. Let's say it can be Derby or MySQL, but the configuration will be differing depending upon the type of cluster. Yeah. So this is what Hive Metastore is. Now that we have seen what is Hive, what are the features of Hive, and what is a Hive Metastore, and in how many different ways you can configure your Hive Metastore. Now let's look at what are all the data types that are available in Hive. You have something like small int, tiny int, and big int, because we'll be using very huge data when it comes to larger data set when it comes to Hadoop. That means in Hive. So in order to make sure your data, all your huge data is being handled perfectly, we have different data types here, and we have Boolean, float, double, right? And apart from this, we also have something like timestamp available in Hive. Yeah. So these are the data types available in Hive. Okay, and the literal syntax examples of each of this data type is provided over here. So you can ask me, what if I have a column with date, right? So until the recent version of Hive in CDH4, we don't have a date data type available to store your date, data of date type. Rather, we used to use something called string to store our data. Okay, so we have another data type called string, which is a normal Java data type or a normal database data type, where you normally store our strings. So even in Hive, we have something called string, which we used to store our date type of data as well in our earlier versions of Hive. So that's it for this particular video, and hope you had enjoyed this video. In our later session, we'll be looking all the Hive commands in practical. Thanks a lot for watching this video, and bye bye.